Hello everyone, welcome to another Math 11 tutoring video, and in this video we will be doing some examples using the theory we just learned from sections 2.3 to 2.4. So without further ado, let's just get into the examples. So first example we have here, number 1, it says simplify f of x equals x squared plus 7x minus 8 all over 2 minus 2x. So again, using what we just learned in the last video, the first step to simplifying this rational expression is to factor the numerator and the denominator. So let's see. We have to factor this simple trinomial x squared plus 7x minus 8. So again, we need two numbers, m and n, that add up to 7 and multiply to negative 8. So what two numbers add up to 7 and multiply to negative 8? Well, those numbers would be 8 and negative 1, right? If you do positive 8 plus negative 1, or 8 minus 1, will give you 7. 8 times negative 1 will give you negative 8, and we put it in this form of x plus m times x plus n, and n is negative 1, so it's going to be a negative. And now let's factor the bottom. From here, we can use common factoring, so we can factor out a 2 from both term 1 and term 2, right? So we factor out a 2, what do we get left with in the brackets? We get left with 1 minus x. And if we use distributive property and multiply the 2 in the brackets, we will get this, right? That's how you can check if it's correct. Now from here, we really can't cancel anything out yet, right? Because these two, it looks like you can cancel them out, but the x here is positive and the x here is negative, and the 1 here is negative and the 1 here is positive. They're exactly opposite to each other, these two factors, right? So what can we do to fix this? Because if they're exactly opposite, right, can't we factor out a negative 1 and just switch the signs? All we want to do is switch the signs on one of these terms, right? So how can we do that? We can factor out a negative 1. So we can leave the top the same, x plus 8 and x minus 1. And from the bottom, if we factor out a negative 1 from this term, right, we're left with a negative 2, and the signs here now are going to switch. Now we're going to have a negative 1 and a positive x. And now we have a positive x up top, and a positive x on the bottom, negative 1 on the bottom, negative 1 on the top. So we can actually cancel these out. But before we do that, let's note the restrictions first, right? Before we divide out common factors, so we just can really see the restrictions before, they're gone, right? So from this first factor, we need to find out what makes the denominator equal to 0, which will make the function undefined. If this factor equals to 0, it'll make the denominator undefined. So what x value makes this factor 0? Let's find out. If we have negative 1 plus x, if this all equals to 0, what is x equal to? So we can add here a 1 to each side, right? And a 1, we just add a 1 here. These two will cancel out, and we get left with x equals 1. And so now that's our restriction. We can write it up here. Restrictions, x equals 1, or x cannot equal 1, actually, right? And so now we can just cancel these out, and we can write over here that f of x equals x plus 8 and negative 2, which is the same thing as saying f of x equals negative x plus 8 over 2, right? You can switch around that negative sign as you wish, or you can even put it here, right? Doesn't really matter. Okay, that's your final answer for question 1. And we don't have any more restrictions, it's just this, right? Because nothing else can make the denominator 0, just that value of x. Okay, on to the next question. We have question number 2. It says, simplify f of x, which equals 4x squared minus 16y squared, all over x squared plus xy minus 6y squared. Okay, so first we're going to factor the numerator, as we did in the last question. So this numerator, it's not a trinomial. You can common factor out of 4, but this looks like a difference of squares, right? Because 4x squared is a squared, you can multiply 2x by itself, right, to get 4x squared. And 60y squared is also a perfect square because you can multiply 4y by itself to get 16y squared, right? So how do we factor this? Again, we put it in the form of a minus b and a plus b, a being the square root of the first term and b being the square root of the second term, right? So if we use that format, square root of 2x squared is 2x minus square root of the second term, which is 4y, then square root of the first term, 2x, plus square root of the second term, 4y. That's the top. Okay, now to factor the denominator, right? This is a trinomial, and it has two variables, but we solve it in the same way we solve all the other simple trinomials, right? The a value is 1. So we need two numbers, m and n, which add up to 1 and multiply to -6, right? So what are those numbers? Now, since we have two variables, we're going to put them in a little bit of a different form. We're going to put them in the form of x plus my and x plus ny, right? So we can get that y squared over here and that xy in the middle, right? So the first number, m. Okay, so first let's figure out what numbers add up to 1 and multiply to -6. Well, what two numbers multiply to 6? 3 and 2, right? And if we switch around the signs, if we make 3 positive and 2 negative, we can say that m, 3 positive, plus n, -2, will get us 1, and m times -2 will get us -6, right? So our two numbers are going to be 3 and -2. So we can say that x plus 3y, and then times x minus 2y, right? If we multiply this together, these two binomials, we'll get this, right? Okay, and from here, do we have anything to divide out? Not yet, but what we didn't see, or what I didn't see at least at the beginning, is that we should have factored out a 4 from this first equation, right? But it's okay if you forgot to do that, or if you didn't see the common factoring from these two terms. We can see that we can factor out a 2 from each term. Same with this binomial, right? So if we factor out a 2 from the first factor, right, we get left with x minus 2y inside the brackets. And if we factor out a 2 from the second factor, another 2, we get left with an x plus 2y, right? All over x plus 3y and x minus 2y, right? And f of x equals, if we multiply these two together, we get 4 times x minus 2y and x plus 2y, right? All over x plus 3y and then an x minus 2y. So all we did was common factor out a 2 from here and a 2 from here, and then multiply the 2 to get 4. Okay, so we bring it over here. And in this case, because we have two variables, we can't really find the numerical values of the restrictions. We can kind of say, you know what, if x minus 2y has to equal 0 for a restriction, we can say add 2y to each side and say that x equals 2y. So we can kind of get the restrictions in terms of y or in terms of x. Like this could also be, you know, y equals, if you divide each side by 2, you can get x over 2. The restriction is y cannot equal x over 2. So we can get the restrictions in terms of variables, but not in terms of numerical values. So we'll just leave that for this question. And what can we not common factor, what can we divide out from the top and the bottom? Well, we have an x minus 2y and x minus 2y, right? Cancel those out. We get left with f of x equals 4x plus 2y all over x plus 3y. That's your final answer. And one more thing from this question, guys, I actually forgot to mention, right? Because we canceled out these two, that means that whatever x value makes this 0 and this 0, these two factors that canceled out, at that x value, we're going to get a whole. So in this case, there's a whole at x equals 1. And this question didn't really ask you to find the whole, but I just thought I'd mention that, right? Just so you know that now for this graph, if you graph it at 1, there's going to be a hole, kind of like that. Okay? Okay, so let's move on. Okay, so moving on to question number 3, it says simplify f of x, which equals 5x squared plus x minus 4, all over 25x squared minus 40x plus 16. So here we have a couple of complex trinomials, right, which we have to simplify. So let's factor the numerator first. So in a complex trinomial, we need two numbers. Let's say there are R and L, which add to B, which is 1 in this case, and multiply to A times C, which in this case is negative 20. We have 5, we have negative 4, C, 5 is A, right? Okay. So we need two numbers which add up to 1 and multiply to negative 20, and we actually have them right here, right? 5 plus negative 4 is 1, and 5 times negative 4, as we have already right here, is negative 20. So we've already found our numbers. So we now have, on the top, 5x squared. Now we're going to do decomposition, as we always do, plus 5x minus 4x minus 4. And again, we haven't changed the equation at all, because if we collect like terms here, it'll go back to just x, right? Now let's move on and factor the denominator. We have another complex trinomial here, but what's different about this one is that it looks like a perfect square trinomial. So as we can see, the first term here is a perfect square because 5x can be multiplied by itself to get 25x squared, and 4 times 4 can multiply by itself to get 16, right? And with these special types of trinomials, right, what the usual answer, the factor version, is in this format: a plus minus b squared. A being the square root of the first term, right, this one, and b being the square root of the second term, 16, right? And the sign between them corresponds to the sign before the c value, which in this case is 40, and the sign before 40 is negative, so we're going to pick the negative sign. And so if we put all that together, square root of 25x squared, it's going to be 5x, square root of 16, it's going to be 4, and the sign before the c value is the negative, right? So if we expand this out, we will get 25x squared minus 40x plus 16, and this is the usual case when we find that there's a perfect square at the first term, perfect square at the last term. We can just put it in this form, right? So that's all factored. I'm going to erase some of this stuff before we keep going. Okay, so the bottom's factored completely, but let's keep going on the top trinomial, the complex trinomial on the numerator. So now that we're in this step, we can common factor out, factor by grouping, by by factoring out a term or a common factor from this term and a common factor from this term, right? So from the first two values, we can common factor out I forgot an x squared here. Excuse me. We can common factor out a 5x from here, right? We get left with an x plus 1. And from the other two terms, we can factor out a negative 4. Factor out a negative 4, we get left with an x plus 1 as well. The bottom is still 5x minus 4 squared, right? Now that we're on this step, we can factor out an x plus 1 from the numerator and get left with an x plus 1 times 5x minus 4 all over 5x minus 4 squared. Now before we factor out anything, we divide out anything, let's note the restriction. The restriction is x cannot equal. So we need to find out what makes this denominator 0. What value of x, right? What value of x makes this factor 0? So if we equate it to 0, right? We add 4 on both sides, 5x equals 4. We divide both sides by 5. we get left with x equals 4 over 5. So now we can say that a value of 4 over 5, if you plug that into x back in here, it'll give you a value of 0 in the denominator, and will therefore make f of x defined because you'll have a number over 0, and we can't have that. And of course, as we know, we will have in the graph of f of x at 4 over 5 x value. Oh, I can't write there. Let me move this. At a value of 4 over 5, we will have a vertical asymptote. So the graph will never touch this line. It'll go everywhere except touch this line of 4 over 5. Okay? So the restriction is x cannot equal 4 over 5, or else our function will be undefined. Now we can go ahead and divide out from the bottom and the top. And let me rewrite this in a better way. So we can divide out common factors. So 5x minus 4 squared is the same thing as saying 5x minus 4 and 5x minus 4. So we have 2 of them on the bottom. This exponent just tells us how many of these factors we have. So we have 2. And from there, we can factor out just one of them, right? With the 5x minus 4 on the top. And we'll have x plus 1 over 5x minus 4. And that's our final answer right there. X plus 1 over 5x minus 4. And you could say from here, if you factor out a 5x minus 4, you'll get a whole at x equals 4 over 5. But we have already a vertical asymptote, right? So the graph will never, right, touch this line at, let me draw the graph so you can see it better, at x equals 4 over 5, right? It's already a vertical asymptote, so the graph will never pass by it, so we really don't need a hole somewhere here, right? We really don't know where it is because the graph never really passes this line, right? So we can just say that we have a vertical asymptote at x equals 4 over 5, so x cannot equal 4 over 5 as a restriction. Okay, and that's it for the video. Thank you guys so much for watching. Always remember to keep practicing, and I'll see you in the next video.